So residuals. Correlation coefficient, our R value that we talked about yesterday, that's that weatherman, okay? The predictability of the model, or how well it will do in its predictions. So the closer that R value is to 1, or the closer the R value is to -1, the better the predictability, the better that model does in predicting things, okay? Think about, like I said, that weatherman. If they had an R value close to 0, I wouldn't trust them in their predicting the weather. Okay? So it says, although R value is an excellent measure, one thing that it does not tell us, it does not tell us whether the model is appropriate, only if it does a good job at predicting. So we had an example yesterday in class where we talked about, it told us that it was, it was the flu cases one. Let's go back and just, you guys don't have to flip your pages. Where was it? No, I can't find it. Other types of regression. Oh, it was here. Okay. This example back here. Okay. When we put this in our scatter plot and we looked at it, it looked linear. The scatter plot looked linear. The question directed us and said exponential, and we also thought about the context of the problem. We said bacteria always grows exponentially. But what if we didn't have the context? We just had these numbers, and we didn't have it saying use the exponential regression. We might want to look at that scatter plot and say, well, that's linear. Somebody else might say, oh, well, no, I think that's exponential. So what the residual value does, it tells us which model is best. Okay, which model is best? Is it best to be linear? Is it best to be exponential? Or is it best to be quadratic? Okay. So let's go back here. Okay, so it talks about the appropriateness of the model. So today we'll examine what are known as residuals and residual graphs to determine if a linear model makes sense. So we've got some information here. It says a skydiver jumps from an airplane and is attached. Microcomputer records the time and speed of the diver for the first 12 seconds of the diver's free fall. So we've got time in seconds is our x, speed is our y. It says find the equation of the line of best fit. Okay, so they're asking us to use linear regression, round both coefficients to the nearest tenth, as well determine the correlation coefficient, okay, and round that to the nearest hundredth. So we've got to come up with, let's kind of jot down what we're going to need. We're going to need that, we're going to need that, and then it says based on the correlation coefficient, characterize the fit as positive or negative, and then how strong a fit. So we got a couple things to answer about that deal with the R value. Create a plot with both the data and the line of best fit shown on it. You don't need to reproduce the graphs. We just need to look at it on the calculator. So let's go ahead, enter this. Let's get our scatter plot, and let's toss in our regression line. Oops. What? What is going on here? Oh. There we go. So I've got my data. I want to look at that scatter plot. Okay. So let's look at it. What does it kind of look like it's doing? What do you think? Kind of looks like it's got a curve to it, right? Almost looks like it could potentially be what? Quadratic, okay? Something going on there, okay? So we're looking at that, but they're directing us, they're saying linear. They told us they want linear, so that's what we'll give them, linear. So menu, analyze, regression, linear. So there's our equation. Line of best fit, okay? Doesn't look great, okay? But like I said, we're doing what they asked. So we've got to write that equation down with slope and y-intercept to the nearest hundredth. No, nearest tenth, right? Round both coefficients to the nearest tenth. And then the r value to the nearest hundredth. So you guys write that down. And now, to get the r value, we got to go back to the list and spreadsheet, right? So go back to your 1.1, and then we've got to go menu, statistics, stat calculations, two variables, right? Okay. We called our first list X, we called our Y list Y, and we're going to click OK. And then we're going to scroll down our title list till we find that R value. Okay? Everybody got what I have? Okay. Got our R value, and here over here on 1.2 we've got a regression line with its equation. Okay. So I've got to write some stuff down. So nearest 10th, 6, is it 6.0? X plus 13.1? Yes? Okay. And then round the correlation coefficient to the nearest hundredth, that'd be 0.94. So what would we say? We got a couple things to answer about our R value. Characterize the fit as positive or negative. Is it positive or negative, the correlation? It's positive, right? Because our slope is positive. And then how strong a fit is it? I'd say it's moderately strong, okay? Moderate correlation, moderately. It's not fantastic, okay? But I'd say it's a moderate fit. Pretty good. Now it says, take the animals out there, rabid animals in the halls. So now let's talk about the new stuff, the residual value. Okay, so what is this? Okay, is linear a good model? Okay. I don't know. Let's see. But let's have the proof to back it up, not just say, well, it looks like it's something else. Okay? So it says the residual of a data point. So here's a big definition, guys, for you to make sure you understand. The residual of a data point is defined as the difference between the observed y value and the predicted y value. Wow. So let's sort of simplify that. The residual is equal to the difference between the observed y value and the predicted y value. So I'm going to call the observed the actual, so I'm going to call it A, minus the predicted P. So a residual is the actual data point minus the predicted data point. The prediction comes from our equation. So it says, using tables on your fill in the table below, round to the nearest integer, the residuals for each. So they just took and reproduced the table here that we have at the top of the page. And now we've got to come up with the predicted y value. The predicted comes from the equation. Predicted comes from the equation. So if I use my equation and I put 0 in for x, what do we get? So I'm not going to do this for all of them because clearly I don't have enough space. 0 equals 6.0 times 0 plus 13.1. What would that give us to the nearest integer? 13, right? Okay, I'm going to erase that just so I've got space. Okay, but I wanted you to see what I'm doing. 13. Now, use the equation again and put 2 in. And what do we get? Who's got it? 25. Okay. Put 4 in to the equation, rounded to the nearest integer. What do we get? 37. About 6. Nice, Liam. You're on a roll. Keep going. What's the next one? Who's got it? 61. Keep going. 73. 80 what? I've got 86 on my paper. What do we have? Is it 85 or 86? 85. It's 85? Okay. We'll go with 85. All right. We good with those? Those came from the equation. Now, the residual is our little formula up here. Actual minus predicted. So residual equals actual minus predicted. So I'm going to take my actual y value and subtract my predicted y value. So what's 0 minus 13? 13. What? 13. 13. Wow. This is a group of accelerated. Okay, what about this next one? 0. 0. One person knew that subtraction. Emily? 11. 7. -1. -11. Okay? So we just calculated the residuals. Well, what the heck does this mean? Okay? We know how to do the calculation. Okay? Now it says sketch a plot of the residuals below. Okay? Your teacher, okay, will show you how to do this on your graphing calculator. Go figure. Okay? The calculator is going to do this for us as well. So I'm going to pause this just to make sure I remember where it is on the calculator. Here we go. Starting it back up again. All right. So make sure you're on your scatter plot. Go to Menu, Analyze. And now this one, we're looking for the residuals, a residual plot. Okay, we've already got the regression in there. We want the residual and show residual plot. Number 2, show residual plot. Jack, you with me? No. You don't even have your calculator in your hand, big guy. Okay. So now, whoops, look at that residual plot. And we want to do a sketch of it. I want to produce this sketch of this residual plot on my paper. What it just did, what it just graphed for us, was our x value, whoops, with that. Okay. Now, go ahead, put that plot on your paper. Just a sketch of it. Okay. Can you see where that first point came from? Okay. That one right there was 0, -13. And then the next one was 2, 0. Okay. That's 2, 0. So just so you see where these points are coming from. Okay, 0, -13. That one right there is 4, 9. And 6, 11. Just so you, like I said, just so you guys can understand where those points are coming from. Okay? We're almost there as to what this plot tells us about the model that we picked. So they told us to pick linear. We looked at it and said, really doesn't look linear, okay? Kind of looks quadratic. This is the proof. When you look at your residual plot, now don't fall into the trap and say, oh, the residual plot looks quadratic. That's not what we're getting at. If the residual plot, guys, this is like the big understanding. If the residual plot has a general pattern to it, that means that the model we picked back up here was not good. Okay? When your residual plot has a general shape to it, which this clearly does, got that nice curve to it, it tells us, it reinforces that the model we initially picked for our regression was not a good model to pick. It backed up our assumption. We're like, yeah, this kind of looks quadratic, but they're telling us to pick linear. That just backed up, yeah, it's not good. Okay? So, do the residuals show any distinct pattern? Yes. Okay? Yes, it showed a curve. Okay? A pretty distinct curve. So let's expand. Okay, this question isn't asking that, but let's add that in there. Okay? When the residual plot shows a pattern, pretty distinct pattern, the regression model was not a good choice. So the residual deals with the regression choice, whether it was good or not. The R value is the weatherman, determines whether your regression is a good predictor. Okay? Two different things. And don't confuse them, because R value is correlation coefficient, predictability. Residuals, I know it starts with R, but it's not the R value. Residuals is the graph, tells us whether our model was a good choice. Alright? Let's flip it. It says, generally, we do not want residuals. This was our little summary that I put on the front there. Okay? We do not want residuals to fall along a curve or make a distinct pattern. Do not want. If so, then it is likely that a linear model, or the model that we picked, is not appropriate to fit the data. And perhaps something else is better. Okay. Good with that? Okay. This and what we summarized on the first page are the same thing. They're saying the same thing, just another way. A school district was attempting to correlate the number of hours a student studies in a given week with their grade point average. I think we did this data before. They surveyed 8 students, and we've got the data. So hours studying Y, GPA, or hours studying X, GPA Y. Find the equation of the line of best fit and the R value. They want us to round to the nearest tenth and the R value to the nearest hundredth. They want a scatter plot and the line graph. You do not need to reproduce this on your paper, right? So I'm going to pause and let's do that. Turn this back on. So looking at that,
Menu, analyze, regression, they want linear. Okay, comes up with that. So we got to jot that down. Then, there we go. Then I've got a menu statistics, stat calculations, 2 variables, and find my R value. Okay, to be that. So let's get that info down. So the equation, nearest tenth, right? Was 73.7. Am I good with that? Yes? Okay. And R value nearest hundredth, 0.88. So we've got our information down. Okay. Now let's do something with it. What is the value of the residual associated with the data point 1194? Okay, so think about what we did on the first page. Okay. We had on the first page, we had, we had our X value, then we had our Y value. These are our actual. Okay. Then we had the predicted Y value. We had to do some calculations there. And then we had the residual, which was the actual minus the predicted. Okay. So they want, what is the value of the residual associated with that data point? So the predicted comes from our predictor. Okay. Our Y equals 1.3. What's the X value that goes with it? What is it? It's 11. 11 plus 73.7. So what do we get for that? Got it. Give it to me nearest integer. 88. Okay. So the predictor gave us 88. The actual was 94. So what's the residual? What's the difference between the actual minus the predicted? 6. You guys are going to need to remember how to do this because there's a question. I can't remember if it comes up on the test or if it comes up on the review. But one of them comes up like this again, okay, in part B. Now it says, produce, using your calculator, the residual graph, okay? So we go back to your scatter plot and menu, analyze, then what? What do I pick next?
Residuals.
Residuals, then what?
Plot.
Residual plot, yep. Okay. Now, let's see were our calculations correct. They want to know what we calculated that the point was 11.6. Okay. Is that correct? Let's see. Because I think we can hover over. Where is, there's 9. 11, 5.45. Pretty close to 11.6, right? That's the one that we just calculated by hand. So do you see if you hover over them, get the little hand to show up, it will give you your data points. Okay? It will give you your residual points. So there's our one that we just calculated. Okay? Produces, okay, we did that. Why does this residual plot show a more appropriate model than the one in exercise 1, even though the R value is worse? So our R value here is 0.88. Back here, our R value was 0.94. Okay, but when we looked at this residual plot, we saw a shape, and we said, okay, linear is not a good model. Look at this residual. Is there really a definitive curve to it? is good. So that means when my residual plot is scattered, that tells me that the model I picked was appropriate. Okay. So, let's go back. So, the residual plot was scattered, indicating the regression model we picked was appropriate. Was appropriate. It was a good choice. Okay. Sorry that was so much.